So in demo 1 we saw how we can communicate one way, sending commands from the computer to the Arduino via the Bluetooth module. I'd like now to be able to have a full duplex two-way communication, so both send commands from the computer to the Arduino, but also get things such as sensor readings from the Arduino via the Bluetooth serial port to the computer so you can display it or log it. That's what I'll do in the second demo. So I have disconnected the Bluetooth module because I'm going to have to upload a new sketch in a minute. And I have connected a simple photoresistor, simple analog device, using a voltage divider. That's another 1 kilo ohm resistor. And the green wire goes to analog pin 0. Red wire goes to power, as always. So I'll upload the sketch. I have to select the USB port for communication, because for demo number 1 I had selected the Bluetooth, just making sure got the right settings, and then upload it. Okay, now I'm done with the uploading. I will connect the Bluetooth module, and my computer has forgotten all about it, so I'm going to have to repair it. Okay, pair. Okay, connected. So let's have a look now at the Bluetooth serial port and bring up the monitor. So you can see that the Arduino via the Bluetooth module is sending sensor readings from the from analog pin 0. So these are the photoresistor readings. I can still send commands and turn the LED on or off. So everything still works, just like in demo number 1. Great. So let's have a look at how this is working. Again, there's nothing here that shows there's nothing here that shows that the communication is happening via Bluetooth or USB. I'm using the same way for grabbing sensor readings from the Arduino in this case, every 1 second. Same method as we saw in the previous lectures. And that's happening down here. So the first part of the sketch is identical to the sketch in demos 1. The only thing that I have added is the reading part. So as long as 1 second or 1000 milliseconds have gone past, then I'm going to go and grab a reading from analog pin 0 and then send a little bit of text to the serial port, which just happens to be the Bluetooth module, since it's really hijacked the transmission pins 1 and 0. That's all there is. Super easy. Now, having to unplug the Bluetooth module in order to switch it off while I'm uploading a sketch to the Arduino because of the receive and transmit conflict with the two serial lines can be annoying. So luckily there is a way to use an alternative serial port pair on the Arduino that is not hardware but implemented in software. What this means effectively is that the USB serial connection and the Bluetooth serial connection can live and be active at the same time, as long as they're not using the two serial port hardware implemented ports. What we do instead is that we use 2 of the other digital pins of the Arduino to simulate a serial port in software. there is a special library. It's called Software Serial that provides this functionality. And looking at my sketch, you can see that I'm initializing the Software Serial port to live on pins 10 and 11. So 10 is going to be the receive pin, and 11 is going to be the transmit pin. So to make this happen, I'm just going to relocate the yellow wire, which is right now hardware receive, to pin 10. And now it's going to be software receive. And the hardware transmit, which used to be in pin number 1, is now going to be in pin 11. So I haven't lost the pairing of my Bluetooth from demo number 2. I didn't unplug it, so it should still work, already paired with my computer. And I'm just going to go ahead and upload the sketch and make sure that I've got the right port. All right, then upload it without disconnecting the Bluetooth module. It's done. Now let's check out, make sure it really does work. It doesn't. Then check to see if I'm still connected, because maybe the connection has dropped out. Okay, and it's not connected, so let's go ahead and redo this connection. A mistake. Should have chosen Bluetooth port. There you go. So my mistake was that I was looking into the USB port to monitor the USB port instead of the Bluetooth port. Yep. There you go. So all this is implemented using Software Serial, and communication is both ways. Great. From these demos, you can see that Bluetooth connectivity can be very simple. It uses a familiar and well understood serial interface, thanks to which no change in code is necessary, except if you desire to use the Software Serial option. Bluetooth modules come in many types. The one I used in these demos are very cheap and simple. They come with limitations, of course, that more expensive modules correct. For example, the HC06 module I used has limited range. I measured it to be 5 meters with clear line of sight, though enough for my users, while most expensive ones can go up to 10 meters or beyond. My module has to be paired every time it restarts. The HC06 also can only act as a slave, which is okay if you want to connect your Arduino to a computer, but not if you want to connect it to any other Arduinos. If you want to do that, then the second Arduino will have to use a more expensive Bluetooth module that can act as a master. For example, the HC05 can do this. As an exercise, try this out. Untether your Arduino from your computer by plugging a battery power pack to its DC input port and removing the USB cable. Confirm that you still have a Bluetooth connection and that you can turn the LED on and off. Add a couple of sensors and transfer the readings to your computer wirelessly. If you are up to the additional challenge, add a couple of more LEDs and control their state by creating appropriate commands that are interpreted by a simple parser, very similar to what was shown in the Ethernet web server lectures.